My name is Castro. I'm going to do a presentation on flight price prediction. This is group one. Uh, the background, flight price fluctuate dynamically depending on airline travel class, number of stops, and booking lead time. This variability impacts travelers and airlines alike. The importance of this study, accurate predictions enable travelers to save money and help airlines optimize better pricing strategies for better revenue management. The problem statement, we aim to build a model that predicts flight prices and provides insight into price trendings and potential delays. Objectives and scope. The first objective was to predict flight prices using using machine learning model. The second one was to provide detailed insight into price trends and airline performance metrics, enable clients to make cost-efficient travel decisions by identifying optimal booking opportunities, and the other one was allow admins to analyze airline trends, pricing strategies, and potential flights. The scope we focused on Indian Airlines, and we included data pre-processing, model development, user, and admin dashboard. We excluded real-time price scraping and international data flights, focusing on domestic routes. Under methodology, we had 4 steps. The first one was data collection and pre-processing. The other one was categorical encoding and one-hot encoding. The third step was machine learning model development, whereby we trained and validated various machine learning model outputs. And the fourth one was machine learning evaluation and deployment. Thank you. That was my time.
My name is Mercy. I'm going to take you through the data source set and description. We sourced the data set from Google, which is the flight price prediction data set. Features include airline, source, destination, cities, travel class, which is the economy and business class, number of stops, durations, days left before the flight, and the price, which is the target variable. Our data set size contains 24,000 training samples and 6,000 test samples with 34 features after pre-processing. The screenshot below shows a snippet of feature handling. Next is the data pre-processing handling features. Steps include, we dropped unnecessary columns, e.g. the unnamed, 0 flights, to reduce noise in the dataset. We also handled missing values by ignoring them in the current implementation, that is for future iterations, which may impute them. We encoded categorical variables, e.g. the class, which equal to economy equal to 0, business equal to 1, and also the stops. So 0 equal to 0, 1 equal to 1, 2 or more equal to 2. We also scaled the numerical features like the durations and the days left using standard scalar to normalize their distributions. Next is data preprocessing, insights from visualization. From the histogram, it is revealed that the flight prices are right skewed, with most prices ranging from 0 to 20,000 Indian rupee, but some outliners reach up to 120,000 Indian rupee. The implications are this outliner may skew model prediction, suggesting a need for outliner handling, e.g. capping or removal in the future iterations. Additional insights includes the median price is around 10,000 Indian rupee, indicating that most flights are affordable for domestic travel. That's it for my presentation. I'll pass it to my next group member.
Hello, my name is Sharon Chepkiroi, and I'm going to take you through price variation by airline. So the observation reveals that the flight price comparison between different airlines, and from the above graph, it shows that the Vistara airline has the highest price, followed by Air India, which is the second, and then the rest are low. This implies that the price varies in airlines with different features. The next slide, price variation by class. So this price varies between classes in different airlines. As shown above, the business class has the highest price, followed by the economic class. This implies that the price varies in classes with different features. I'm going to take you through a machine learning model, that is data splitting and training. This shows that we split the data set into 80% training and 20% testing. So we used a random set of 42 to ensure reproducibility of the split. So from the above screenshot, it shows data splitting to training and testing databases. Thank you, and I will pass the next to the next group member.
Okay, my name is Konski Chumba and I'm going to do a presentation under training process. We train each model on a training data to learn different pattern in different flight prices. We also evaluate model performance on test data using mean absolute error, mean square error, and R-square matrices. Under machine learning validation, model performance metrics, the result shows that linear regression had a mean absolute error of 4,500, mean square error of 46 million, and R-square of 0.9. Under random forest, we see that we got a mean absolute error of 1,079, mean square error of 7 million, and R-square of 0.9. Under gradient boost, we got a mean absolute error of 2,900, mean square error of 24 million, and R-square of 0.9. Under gradient boost, we got a mean absolute error of 1,900 and mean square error of 11 million and R-square of 0.9. This shows that the best model is random forest achieved with the highest R-square of 0.9 and was safe for deployment. Observation shows that nonlinear models under random forest and gradient boost outperform linear regression significantly. Also, we can see we got some insights that shows random forest excel with an R-square of 0.9, explaining 98% of the variance in flight prices. Its mean absolute error of 1,079 indicates high accuracy, with predictions off by about 1,080 Indian rupee on average. Nonlinear models like random forest and gradient boost perform better than linear regression, confirming the complexity of the price pattern.
My name is Timothy Keegan. I'll be taking you through model deployment. I'll also take you through a little bit of our code, and thereafter we'll do a little demo. So we deployed our model using Django as a base framework because it offers a robustness alongside scalability while providing essential features that integrate security capabilities with database accessibility. We also utilize the RESTful API, where the user's inputs are managed through the API, which accepts information including the airline selection and travel routes, along with class types and number of stops, in addition to available days before travel. And with this, we can calculate our price estimates. On the right here, you can see we have an image showing our code. Next is a little bit of the dashboard for the users. So the travelers will input the flight details like the airline, classes, stops to get the price predictions. Our system it deploys the dynamic charts on price trends and delay rates. That's based on the departure time and airline. And our system has been built on HTML, CSS to improve our UI. We've also used the JavaScript. Specifically, we've used chat.js. Django templates has also been utilized, and more so the RESTful APIs for real-time model outputs. For the database, we've used the SQLite to log the queries. This is our admin dashboard. Admin dashboards basically shows the number of predictions or the history of predictions. So from here you can see that we've done a number of testings, showing around 13 testings done so far. I'll take you through the code and on the code, the first part that I would like to go through is the README part, where it gives you the instructions on how you can run this system in your machine. And the first thing, or the first step, is to install the Python. Once you've installed the Python, you need to create the virtual environment. The next is to activate your virtual environment. And after you've activated your virtual environment, you can now run or install the dependencies or the libraries. All these libraries have been packaged in here, and we've named it requirements.txt. The next step is you have to install the static files. The static files are the JS, the CSS, and other files that builds the UI for our system. We applied migrations for the database, and on this we are using Python manage.py, make migration. We also use migrate. Once you've done that, you can run the application using manage.py, and then you run server. Okay. Now our system, I'll show you a little bit on the Flight API. We have a number of templates. We have the index template, which is the user part, and then we have the admin dashboard.html. This is the admin part. From here, we can also go through the view. The view is a UI where the user interacts with the system. And to integrate this with our model, we have loaded our model in the setting part. So you can see our model part and models, and then best model, as mentioned by one of my colleagues. So once this is loaded here, or once this variable has been loaded there, you can go to the view parts, and we've done a function. We call it a load model. This load model will load our model using joblib, which is one of the requirements or one of the libraries that we've imported. We have also created a number of functions, for example, the one to predict the prices. So the function of predict price with feature dictionaries. We've also done the predict delays. And also after the predict delays, you can see the index part, which is now our user site. I'll show you through the demonstration. We can do one demonstration. And assuming you are doing the Air India or the Air Asia, we can say the Air Asia is moving from Delhi to Mumbai. Our time of departure is, you can say you want to like travel at night and you want to be there in the morning. You only want maybe one stop. You're traveling on economy, and the time of, or the duration is basically the time between the travel between Mumbai and Delhi, say 8 hours. So days left is the number of days remaining for your travel. You can say 8 days. And now we can do our predictions. From that, you will see that our charts will dynamically move. Perfect. But that is our user part. You can also go to the admin dashboard where it shows you a number of predictions done. Thank you.